Hello, we are going to talk about chapter, we'll still continue to talk about chapter 4, and the content is including four parts. Basic indexing and slicing. The second is Boolean indexing. The third is fencing indexing, and the fourth part is transposing arrays and swapping access. So let's start. Let me share my screen with you. So let's check at the indexing. So for the array, what do we have? An array here, which is similar to a list, right? Only difference is the data type here is an array. So we want, so we have start point, and end point, and it will not include the end point, right? So an important thing is that data, so actually in array, the sizes of fields on the original array. This means that the data is not copied, and any modifications to the field will reflected in the source array. So we want to assign number 12 to these three values, and then let me run it. And then you can see what happened, that the original array is changed, right? And another way to do it is that so we still have the original array, and then I assign a value slice to this part, and then we can assign a number here. Then let's check what's in array right now. See, there are, when we change, even though we assign this slice into a variable, we change this variable, then the original array will be changed. So that's the part that I want to let you know. And I mean, as NumPy has been designed to be able to work with very large arrays, so we could imagine performance and memory problems if NumPy insisted on always copying the data. So that's why we are not copying the data, but we just replace the data when the sizes are changed. Then let's check the 2D array. So we get the second element from this array, and let's check the 3D array. Okay, I got the first element. There are two elements in this array. Let me show you what this array looks like. So it looks like this, and I mean, even though we are talking about 3D array, but it's not that hard, right? There are still some rules that you can follow to get what you want from the 3D array. So for example, I want that right now I want to change everything in here in the first element into 12. So what should I do is that, okay, I make first, I identify the first element and then assign 12 to it. And then I want to change it back, change everything back, because I have already stored the original value in this old value variable. So I can actually change everything back here. Let me check. Okay. So right now everything goes back. Everything went back, okay? So which is quite, I think it's not that hard to do like in slices here. And another thing about, about array, about slices, basics indexing and the slices is that, so you can actually, use a comma and then the first part actually show you the row the row range, and the second element show you the column range. Actually, it's very similar to like illoc, right? Illoc, that kind of method we will mention later. So let's go to the next thing, which is Boolean indexing. So Boolean indexing is very interesting too, because see here we have one array with a name, with names, and then we have this data array, and when we put this condition in the data array, then we can get everything that is true. So we can see here, okay, the first element and the third element is true. So it will return the first and the third element from this data array, right? So the only thing we need to remember is that the Boolean array must be of the same length as array access is indexing. We can even mix and match Boolean arrays with slices and integers. So how to do it with integers? Here is an example, right? And another thing is that you can do also like not equal to bar here. Okay, not equal to, then we need a parenthesis here. See? So it will just show the second element of data. So the next part we want to look at is that we want to look at selecting two of the three names. Actually, we only have two names, right? But we can add something. Add one person name is Lily. Okay, now we have three names, and here we need to have three of them. So right now I want to find two people's data, Bob and name equal to Lily. Okay, there's no and, but we have this one. This operator means all. Actually, it's all. This one means and. Also names. Okay, this is like a condition, or like multiple Boolean conditions. And so in data, what happened? Data mask. In data mask, what happened here? Okay, so okay, we have this mask and data mask. Okay, it seems like there is, let's check what's in mask. Okay, so in mask, false, 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 false. Okay, because no element in this array is Bob and Lily, right? So we only have one choice. See, so you can see, okay, the first one is Bob, yes. The Nancy, no. Bob, yes. Lily, yes. So when we do the mask, we will get what we want. And then let's go to the next step, which is setting values with a Boolean arrays works in a common sense way to set all of the negative values in data to 0. And what we should do is, okay, I do not want anything. I want to change anything that is less than 0 to 0. So let's check the result. Okay. Yeah, we have done that successfully. So let's go to the next part, which is called fancy indexing. So for fancy indexing, I mean, how fancy it is, right? How to do that? I mean, so fancy indexing is a term adopted by NumPy to describe indexing using integer arrays. But first, let's get an array. Okay, I have this empty 8, 4, 8, 4. So what I get, I think, is 8 rows of 8 rows and 4 columns of data with or 0, not 0 or empty value. What happened? Okay, it didn't work because there are double parentheses. Oh, still it didn't work here. Array np.empty 8, 4. Okay, we didn't run anything here, which is okay. So I think for empty, it's not all empty value, right? There must be something in there. So let's check it. We can see return new array of given shape and type without initializing entries. So it's kind of a random create, yeah, an array. Okay, so let's check out. Actually, we can change everything in array. So we use for loop to change everything in this array to the into the index or to the length of the rows. So to select out a subset of rows in a particular order, you can simply pass a list of ND array of integers specifying the desired order. So how does it mean? It means that, okay, right now, I want the 5th and I want the first 5th and the first row. So that's how I get that. And I also want, okay. So I use negative indices, select rows from the end. So I want the last two. Okay, you can see the last 2 rows here. And then we can parse the multiple index arrays too. There's some things that's like different stacks or none or one It stacks a one-dimensional array of elements corresponding to each tuple of indices. So array np dot, I will create a new array. Again, create a new array here, which is, okay, array shape 8, 4. Okay, array shape is not correct, right? Okay, so here is what we get, this new array, and then what I want is first, actually is second. I want the second row, first one. I want first, so I want this one, these two, and this one. And what I will do is, okay, 1 and then 2, 2, 2, and I just mention I want this one, right? Okay, 3, and then what I want is, okay, we can check from the column side. So I want okay, throw this one and then 3. So this one, this number. So that's how I get this number, right? Next is okay, I don't think this is so fancy, you know. I just think that, okay, it seems you can actually identify some value, some exact value. And I don't think that is a fancy way to do that. Maybe somebody think this is fancy. Okay. The next thing about fancy, okay, about fancy indexing is like this. So, okay, what we have is here, right? So in this way we get, okay, we get this second row, third row, and the fourth row. I mean, sorry, second row and the third row and the third row again and the fourth row. And then what we add is this. It seems like we get okay, so we can change the order here. We can change actually the column order here. So that's the fancy part. I think that's the most fancy part. So let's check the last thing we will talk about today, which is transposing arrays and swapping access. Okay, so that's this one. Let's look at array is equal to np.a range 15 here. And let's do the reshape again. So we are creating something. We are creating a new array again, right? See it clearly. So this is array. So how about we do the transpose? Okay, if we want to do the transpose, so T. So you can see that actually we in the past, before this transpose, the array is has 3 rows and 5 columns, but right now it has 5 rows and 3 columns. So that's how we do this transpose. So when we are doing the matrix computations, we may do like np dot. We'll use it a lot. So for example, okay, we can do np dot then array dot t array. We can see a result. So this is how we do matrix computation. Then for higher dimension arrays, transpose will accept a tuple of access as numbers to permute the access. So how to understand this? Let's go to check our 3D array, which is array 3D. Yeah, that's what we have before. So we want to, okay, array 3D dot transpose, then parenthesis, and then what we want is we have, okay, 1, 0. Access don't match array. Then check what happened here. Okay, still access don't match array. So let me check what happened. Wait a minute. So for higher dimensional arrays, transpose will accept a tuple of access numbers to permute the access. Okay, so in the past it looks like this, but right now it looks like this. It seems like the exchange. I mean the second element of this main first element changed to the first element of the second main element, right? So that's what happened here. That's the transpose, and here the access have been reordered with the second access first, the first access second, and last access unchanged. Then simple transposing with dot t is a special case of swapping access, and the array has a method swap access, which takes a pair of access numbers and switches the indicated access to rearrange the data. So for example, we still use array 3D as an example, and then we have SWAP, AXES, and okay, so this is the result. That's all for this video, and we will talk about universal functions, about array, and also array-oriented programming with arrays for next part. And I want to finish chapter 4 actually in next video. So bye. See you later.